All right, back page. We're getting a lot of practice here, okay? Y equals secant to x to the third power is a little different than 3 was because my exponent is with x now, not the secant. So there's a difference here. Okay, so this is like secant x to the first power. So we're just going to take the derivative of the secant, okay, and then the chain rule times the inside. So the derivative of secant x is secant x tan x. Okay, so the x here, whether it's x to the third or not, like think about substitution, that's just going to be whatever on the inside of your parentheses. Like here it'd be x to the third, here it'd be 3x over here for number 5. Okay, the inside doesn't change. So the derivative would just be y prime equals secant x to the third tangent x to the third, but there's a function inside, so we got to do our chain rule times the derivative of the inside, which is 3x squared. Okay, so y prime equals 3x squared secant x to the third tangent x to the third. Oops, I put one too many parentheses there. Okay, secant x to the third tangent x to the third. Then we have times our chain rule, 3x squared. Okay, that's 4. All right, number 5, we have 2 functions here. We have 2x, and then we have sine 3x. Those are 2 functions together. Okay, so we've got to do our product rule here because it's a function times a function. So the product rule is the first times the derivative of the second. Okay, so the derivative of sine 3x is, well, the derivative of sine is cosine, so cosine 3x, and then chain rule times 3. So this would be 3 cosine 3x. Okay? So it's the first, d last, or d second, whatever it was in our notes, okay? First time the derivative of the second, which is 3 cosine 3x, we just found. All right, plus last d first. I think we did front d back, but whatever. You know what I mean. Okay, so sine 3x is the last function times the derivative of the first. The derivative of 2x is just 2. Okay, so that's our product rule with a trigonometric function. So y prime, 3x has to stay there, but like all your coefficients can be simplified and multiplied together. So 6x cosine 3x plus 2 sine 3x. All right, that's your derivative for number 5. Okay, number 6, I'm running out of room, so I'll just do it below. 6 is y equals cosecant theta to the third power minus 5 theta. Okay, so if I'm finding y prime, I'm really just taking the derivative of the cosecant, keeping this the same wherever the x would be, and then taking chain rule. Okay, so the derivative of cosecant x is cosecant, negative cosecant x, cotangent x. Okay, and instead of x, we're just going to have our entire theta to the third power minus 5 theta. So whatever x is, that stays the same. Okay? So let's do that first. Well, y prime equals negative cosecant theta to the third minus 5 theta cotangent theta to the third power minus 5 theta. Okay? Then we've got to do times our chain rule. So times the derivative of the inside, which is just theta to the third minus 5 theta. That derivative is 3 theta squared minus 5. Okay. All right, so our final answer here would be y prime equals 3 theta squared minus 5. Oh, and there's a negative, so I'll pop that in front. Okay, cosecant theta to the third power minus 5 theta cotangent theta to the third power minus 5 theta. Okay, that's y prime. And now your mind's probably blown, like, oh my gosh, there's so much going on. Okay, but just take it one step at a time, rewatch each problem if you need to. Okay? All right, let's see. We'll see how long this ends up being, but we're only at 6 minutes right now, so let's keep doing some more. Okay, so 7 is just whatever the derivative of sine is, keeping this the same times the chain rule. Okay, plus, same exact idea here. Secant, whatever that rule is, keeping 6x the same, and then times the chain rule again, okay? So y prime. The derivative of sine is cosine, so this will be cosine 2x to the third times the chain rule right away, which is 6x squared, okay? Then plus the derivative of secant x is secant x tan x, so plus secant 6x tan 6x times the derivative of the inside, 6. Okay? So y prime equals 6x squared cosine 2x to the third plus 6 secant 6x tan 6x. Okay, that's your y prime there, your derivative. All right, 8 is just whatever the derivative of cotangent is times the chain rule, the derivative of the inside. So hopefully you're starting to see, like, it's not quite, like, you can break it down and not make it quite so difficult. All right, so the derivative of cotangent x is negative cosecant squared x, and I need to keep this the same, so t to the third plus 8 times the chain rule, so times 3t squared. Okay, that's the derivative of the inside. So we'll have y prime equals negative 3 t squared cosecant squared t to the third plus 8. Okay, now y number 9 is a tangent, so you'd have to do the tangent, then you'd have to do the chain rule, which is the derivative of x over x plus 1. Okay, so let's first find the derivative of x over x plus 1. Let's find what that y prime is, and then we'll put it with tan. Okay, so all right, so this would end up being x times x plus 1 to the negative 1, and then you have a product rule. Or you could do the quotient. We haven't practiced the quotient, so let me go ahead and do that, sorry. Okay, so low d high will be x plus 1 times 1 minus high x d low x plus 1 all over low squared. Okay, so that was my low d high minus high d low. Okay, I did that wrong. So the derivative of low is just 1. Sorry. The derivative of low is just 1. Okay, all over low squared. Low. All right, so this ends up being x plus 1 minus x all over x plus 1 squared. Those x's cancel, so I'm getting 1 over x plus 1, the whole thing squared. That's the derivative of the inside, okay? So when we do 9, y equals tan x over x plus 1. When we take y prime, we're just going to treat that tangent rule, which is secant squared x, and then keep this the same. So we'll have secant squared times x over x plus 1. But then chain rule, we got to times that by the derivative of the inside, which we found on our own first. And I definitely recommend you do that. You do that first. Okay, so I could rewrite that as a fraction if I had room, but for now that's fine. Okay. All right, I'll just run through 10, 11, 12 really quick. So 10, product rule. We're going to take the first times the derivative of the second, and cosecant is negative cosecant x, so 4x, cotangent 4x, okay? Then times chain rule 4, the derivative of the inside. So this ends up being negative 4x to the third, cosecant 4x, cotangent 4x. Okay, that's 10. All right, 11 is low d high minus high d low over low squared. Okay, so 11, low d high x squared times derivative of sine x is cosine x minus high sine x d low 2x all over low, so x to the fourth. Okay, so this for 11, y prime would be x squared cosine x minus 2x sine x all over x to the fourth. And don't worry about simplifying those x's for now. Let's just stick with that, okay? X and x could come out of all of them. All right, last one. So there's 2 y's here. I just meant 1, obviously. So sine cubed x plus cosine cubed x. This one's important. I'm going to show you as if it was sine x to the third plus cosine x to the third, and that may help you remember the power rule a little bit better. Okay, so we have to do a power rule and a chain with both of these. So y prime equals 3 sine x to the second. Okay, this is your inside function. What's the derivative of sine x? Cosine x. Okay, plus, this is going to follow the same idea. So you take 3 times the inside to the 3 minus 1, 2, okay, times the derivative of the inside, which is negative sine x. Okay, so let's simplify here. Y prime equals 3 sine squared x cosine x. And there's a negative sine x here, so negative times positive 3 would be minus 3 cosine squared x sine x. Okay? And if you could get and understand 10, 11, 12, then you're doing really awesome at these. That's it.